Now that we know the basics about the architecture of a network router and the elements of it making forwarding of the packets possible, let's start learning about the IP protocol, an important element of data plane defining the network addressing in the network layer. The network layer of the Internet consists of a set of protocols running in data and control plane. Routing protocols run on a per router control or SDN controller in a centralized way. They implement path selection mechanisms running at the control plane, resulting on the forwarding decisions written at each router's forwarding table. Other protocols running at the network layer are the IP and ICNP protocol. IP protocol, which defines the datagram format, also performs the most important function of this layer, addressing. ICNP protocol, Internet Control Message Protocol, is used for network management and control and error reporting. In this step, we want to explore the IP protocol. The first 4 bits of the IP header determine the IP protocol version. The router will look at this field and will know how to interpret the rest of the datagram based on the version of the IP used. This format that we are going to discuss is for the IP version 4. The next field is the length of the header. IP header has multiple optional fields that can change the length of the header. The header length specifies where in the datagram header fields are finished and the payload data starts. The total length is 2 bytes that specify the length of the datagram. Since it is 2 bytes, it theoretically can specify up to 65,535 bytes for the length, but a typical IP datagram is about 1,500 bytes. TOS, or type of service, specifies different types of IP datagrams. These bits could be used, for example, for differentiated services or explicit congestion notification. Protocol field specifies the upper layer protocol. This field is typically used at the destination. Identifier, flags, and fragment offset are used in IP fragmentation and reassembly, breaking down IP datagrams and putting them together again when necessary. Header checksum, known as Internet checksum, is used for error detection at the routers. Source destination and IP addresses are used for addressing purposes, and option field is available to allow the IP header to be extended to include additional required information. The payload section, usually carrying a TCP or UDP segment, or sometimes other formats such as ICMP messages, is the main section of the datagram. Without the options, IP datagram has 20 bytes of header. If it contains a TCP segment, which also has 20 bytes of header, the total overhead for carrying an application layer data would be 40 bytes. Note that application data will also have header overhead, which will vary based on the application protocol used.